Okay, Math 12A. Today is just, there's no new work today. It's just catch-up day. If you're trying to catch up on things, whether it's my class or someone else's, you can be doing that. If you need to finish up something, or if you have a test that you need to be studying for physics, then you can be doing that. But I did have a couple of questions for those who've handed things in. So there were some questions from page 488, which is the length of a tangent. So page 488, I'm going to go over number 62 and 64. And then I make notes while I'm doing this. And then on page 497, which is the sine, cosine, and tangent, so far of the people who've handed it in, and it's not due yet, I get that, but so far of those handing it in, number 25 was a question, so I might as well do that and get that taken care of as well. So I'm just going to do those 3 questions. That's all we're doing today. My dogs are hungry. I haven't fed them yet. So we're going to do this as quickly as possible so that I can go feed my dogs. All right. So page 488, number 62 says, find the exact length of a tangent to the given circle from the given point and express radical answers in simplest radical form. So x plus 3 squared plus y plus 2 squared is equal to 4, and the external point is -5 and 2. So again, I need this, maybe you don't, but I need this. The center of my circle is -3 and -2, 1, 2, 3, 1, 2, and the radius is 2. So it's an itty bitty little circle. And the point is -5, 1, 2, 3, 4, 5, and 2, 1, 2. So if from this point I draw a line to a point of tangency, how long would that line be? So I know that the radius is 2. And I know that these 2 lines are perpendicular to one another, because a tangent line and a radius are always perpendicular to one another at their point of tangency, the point at which they meet. So if I then draw a line from the center of the circle out to the point, I now have a right angle triangle. I know the length of this line because it's a radius, it's 2. I actually have no way to figure out the length of that line, but I do have a way to figure out the length of this line because I know this is -5 and 2. So let's say that's x1 and y1. I know that the center of the circle is -3 and -2. So let's say that that's x2 and y2. I can figure out the length of this line right there, which would be the hypotenuse of that triangle. And I can do that by doing the length of my line formula, which is the square root of x2 minus x1. So -3 minus -5 squared plus y2, which is -2 minus 2 squared. So -3, hold on, it's y2 minus y1, so -3 minus -5, so that should actually be +5. So -3 plus 5 would be 2, squared would be 4, -2 minus 2 would be -4, squared would be 16, and so it would be the square root of 20. So this side would be the square root of 20. Now that side is the hypotenuse to the triangle. And I know that a squared plus b squared equals c squared. So a squared, we'll call this a squared plus b squared. Well, if that's b, that is 2 squared, is equal to root 20 squared. So a squared plus 4 equals 20. So I'm going to move this over here and subtract it. So a squared would equal 16. So a would actually be 4. I don't need to simplify that down, nothing, because the answer is just 4. So that is 62. 64 would be done exactly the same way. So if you're understanding the method, but you're getting something wrong in one of them, it's likely you've messed up a sign or something little like that. You really, as long as you know the method, that's the important part. So 64 is x squared plus y plus 3 squared equals 39. And the point is -2 and -9. So again, the circle, the center is at 0 and -3. 0 and 1, 2, 3. That's the center of the circle. The radius is the square root of 39, which is like 6 point something. So 1, 2, 3, 4, 5, 6, like, we'll call it there, okay? The point is -2 and -9. So we'll just say that's here. And so if we draw to a tangent point, let's say that's the tangent point, the radius is the square root of 39, right? Because this is r squared, so r is just the square root of 39. You don't need to change it into a decimal or anything. You could just leave it as root 39. Sorry. The center of the circle is 0 and -3. This point out here is 2 and -9, so I can figure out the length of this line. If we say this is x1 and y1 and x2 and y2, again, it doesn't matter. You could make this x2 and y2 and this x1 and y1, doesn't matter. What you can't do is say this is x2 and that's y1. You can't, like, if that's 0.1, they're all 1s. If that's 0.2, they're all 2s. Okay. So the square root of x2 minus x1, so -2 minus 0 squared plus y2 minus y1, so -9 minus -3, so really plus 3 squared. So -2 minus 0 is -2 squared is 4. -9 plus 3 is -6 squared is 36. So this is the square root of 40. And again, no need to simplify that at all. Now remember, this is what I'm trying to find. So if I know that that's a right angle, and I know Pythagorean theorem, a squared plus b squared equals c squared, let's call this a. A squared plus root 39 squared equals root 40 squared. So a squared plus 39 equals 40. I'm going to move that over there. So a squared equals 1. So a is 1. So this line would actually be very short. I don't have that drawn very accurately. Okay? And that's what I get. Now, if I have those wrong, I have not checked the answers at the back of the book. Hopefully I'm right. But if I'm wrong, then I've done what I said you probably have done if you know your method and screwed up a sign or something. All right, last one is actually in the Sakatoa section. They're so hungry, they're coming up to get me. All right, Wicket just came up to get me. Yes, Wicket, I know. I just have to do one question. It won't take long. It won't take long. I'll be done like super fast. All right, so page 497, number 25 was the question. So in number 25, they say you have triangle ABC. I don't care how you draw it. Doesn't make any difference. But angle A is your 90-degree angle. So there's my 90-degree angle. A angle B is 55.1, so I don't know, I'm going to call that B, 55.1. If you called that B, that would be fine. It shouldn't affect anything. And little b is 4.8, so little b would be over here. So this is 4.8, and the last one is C. So I am looking for little a, because it's directly across from angle A, and little c, because it's directly across from little c, and I'm looking for what is angle C. So again, there's lots of different ways to do this. I will say, and I forgot to say, I usually say it when I'm teaching, but I forgot to say it, and it actually did catch somebody, and that is, make sure your calculator's in degrees. Make sure your calculator's in degrees. It should say, like on my calculator, it says DEG in this little window. Some just have a little D. I like it better when it actually gives you a little bit more of a word, but anyway. So I'm looking for angle C, I'm looking for side C, and I'm looking for side A. I'm looking for those three. I'm going to find angle C first because I think it's easiest. I know that there's 180 degrees minus 55.1 minus 90 degrees because those are the two angles I know. And so that would be 34.9 degrees. So angle C is 34.9 degrees. Please be clear when you're doing these questions. Either put C equals and have it there. I like to put little titles so that, like, I know whatever's under here, you're working on angle C. Whatever's under here, you're working on side C. Just find a way. You do what seems logical to you, but do it in a way that is clear. Remember, I'm not in your head when I'm marking these things. So, little c, let's say I want to find that. If I use angle B as my reference angle, I know my opposite side, and angle C would be my adjacent side. So opposite and adjacent would be tan of 55.1 is the opposite side, which is 4.8 over C. I'm going to multiply both sides by C, so I would have C times tan of 55.1 equals 4.8. So I'm going to divide this side by tan of 55.1. So I'm going to divide this side by tan of 55.1. I need some space, so I'm going to erase that. Wow, Wicket, you are being good. I shouldn't have spoken his name. And so C will be 4.8 divided by tan of 55.1. And I get that that is 3.3. And they say round answers to the nearest tenth. So there we go. C is 3.3. So now I'm going to look for A. Now again, you could use sine or cosine for this. I'm going to trust myself, and I'm going to say, I'm going to trust that I got this right. I'm pretty confident I did. It doesn't seem like an unreasonable answer. If that was 4.8 and I got this was 527, I might kind of question that a little bit. But I didn't. I got something that makes sense. So I'm going to do that A is 4.8 squared plus 3.3 squared would equal A squared, right? Because A is my hypotenuse. And so 4.8 squared plus 3.3 squared I get is 33.93. That is my A squared. And so A is the square root of that. So I'm going to square root my answer, and I get 5.8. Again, if I'm doing my hypotenuse, it should be the longest side. If I got that this was 3.3 and this was 4.8 and I got that this was 1.7, I would know that's wrong because that's a hypotenuse. It should be the longest side, okay? Now again, you may have done number 25 and you may have approached it differently and still got the same answers. That's fine. What's not fine is if you did it differently but didn't get the same answers. You might be off a little bit, especially tan. Tan tends to be off just ever so slightly. It's the odd one. So if you end up using tan, sometimes that one will end up like someone else will get 3.4 using COAS or something, but using tan you get 3.3, but it's fine. So that's how we go about doing that one. No homework today. Today is just here's some answers in case you were questioning some things, and that's it. So we'll talk to you again on Wednesday.